Well, welcome back to Module 8, the final module. It's kind of sad. We spent all day with you and or evening, depending where you are in the world, and we've enjoyed our time with you. By the way, Tobias and I both shot out to the local bank, and we were not able to pull off what we would. So apparently they're running V4 at the local bank at least. So just to let you know, most banks are at V4. So we don't want to plant any bad seeds. Like I'm going to go try this tonight. So we just tested it. It's all good. V4 is out there for most banks, so you probably don't want to try what we were talking about earlier on. So what we're going to do, what we're going to focus on now, folks, is retrieving SQL Server metadata, and we're going to look at a couple different ways we can do that, and then we're going to look at query performance, ways to monitor query performance, and ways for us to improve query performance. So this is the final module, and again, it's kind of sad, but we're going to talk also about stored procedures. We talked a little bit about how to use them and where they come into play and everything, but we're talking about creating and executing stored procedures in this final module as well. So let's go ahead and move into system catalogs in DMV, dynamic management views. And system catalog views are built-in views that give you information about the system catalog, oddly enough, right? You can use any standard query method to return metadata. You can look at column lists, you can use joins, wheres, order bys, and some of these views are filtered that's going to display only certain objects for you. So what we're seeing here as an example is selecting name, object ID, schema ID, type, and type description from assist.tables. And this is going to be it's going to include display content for us that's going to include information about the system objects. Now, with that said, because we went to sys.tables, we also have another one called sys.objects. So the first command returns information pretty much about user tables, but the second command returns information about user objects and system objects. So you'll get more information, but maybe you don't want all that information about the system information or the system objects that are available out there. Another way we can retrieve information is using what's called information schema views. These return system metadata according to the ISO standard, so they can be used by third-party tools. They map the standard names like a catalog and your domain to your SQL server names like your database user-defined data type. And as you can see here, I can retrieve information from these information schema. So the first one that we show here is .tables. I can retrieve information about the different tables that are being used by SQL Server, how the columns are being used by SQL Server. And again, here I can get a little bit more specific. This would return everything about every column. I want to find out where business entity ID is being used. What table in the schema or in the database is business entity ID stored in? So if I need to make a change to that, I'll understand the repercussions or the impact if I need to change that, as an example. So I can actually go in and throw a where clause on this and return that. Of course, you can throw an order by in here and sort it so you can see where the business entity ID is sorted by table if you wanted to. So it's just a way for us to retrieve metadata about the system or about how SQL Server is functioning. We also have functions that we can use. We've seen a couple functions here. We've got the select version, and we have the two at signs, and the select version for that returns the SQL version. We can also look at the product version. One will show you the version name, and the other one will show the version name and the number associated with the version. Is it version 11 dot whatever it might be for SQL Server 2012? You may be concerned about the collation that you're using with your SQL Server environment. SharePoint requires a unique collation. Your default collation out of the box is not used by SharePoint. So I may want to determine what the collation is for a SQL Server instance before I install SharePoint, before it starts communicating with that. So I can use a server property called collation to determine what collation is being utilized for this instance of SQL Server that's installed.
And we can just mention that these at something Nilatic functions or these called global variables, but they have nothing to do with variables. They're just functions that don't accept parameters. And these are mostly there for backwards compatibility. So typically they're replaced by database property EX, column property, server property, and so on.
So yeah, so again, what we had talked about earlier about the idea of like some of the functionality you've seen for several versions, and it just kind of hangs out for this because we're kind of used to it, and we want you to be able to continue to use that. But as you're looking around and working with SQL Server, see if there's a better, maybe more improved way, performance-wise, that may have another option for you to retrieve the information or perform the task that you're trying to perform here. We can query DMVs and functions. Here's a dynamic view that we're looking at here. Select session ID, login time, and program name. And we're going to retrieve that from this assist.dm_exec sessions. And I can specify, like I said, with a where clause in there, what I want to be able to do with that. Same with the dynamic management functions. Then when they're queried as table valued functions, we mentioned those that are on. We can go ahead and do a select statement on that, specify what type of view I wanted to reference, and specifically a specific object. In this case here, we're looking for that sales order header object to find out or retrieve information about that.
And we have a very large number of DMVs and DMFs, so dynamic management functions and views. So it's definitely useful to spend some time in going through what they are, as this will help you with either debugging issues in the server that you're finding to make your app faster or whatever it is, or maybe you want to build some automated monitoring. So it's worth spending some time going through all of these just so you get at least a hunch of what you can actually see. And this is one of SQL Server's strengths, is really the amount of monitoring we allow you to do. It's actually quite impressive.
Yeah, and that will take some time to understand those, but they are very powerful and worth doing it. And there's nearly 200 dynamic views or DMVs in SQL Server 2012. And again, they include information about catalog information, administrative status information. The DMVs are server scoped at the instance level or database scope, depending on what you're looking for. The underlying structures may change, so a lot of people, what you don't want to do is write a select statement against a specific DMV and keep that and think that's going to be good forever, because they do tend to change. So it's good to understand what's available out there and be able to understand that you can query them, but be careful about writing procedures that's going to go out and execute against them in the event that they do change. And there's different categories of these DMVs. There's database category. There's query execution related categories. There's I/O statistics categories for your input/output. There's operating system or SQL Server operating system information that's available to you. And there's a category on transactions. And we saw how powerful transactions are and how important they are for us as well. So these are all types of views or categories of views that are available out there. And there's a slew of them to go through. I already used plethora, so I can't use that again. I'm going to switch to slew now. A slew of them out there to go out and view. So you want to go ahead and peek at those. All right, so system catalogs and DMVs. Are there any special ones that you like to show when you do demos, or?
No, there's plenty of them.
So many of them.
Yeah, but DMExec overall is one of the ones that you use quite frequently, as well as DMOS to look at different weight stats in the engine. So typically when you're looking to improve performance, a big thing for you is to look what is the server actually doing, and if it's waiting for something, what is it waiting for? So it may be waiting for I/O, for example. It's waiting for the disk. If it's waiting a lot for disk, you may want faster disk or more memory or things like this. So it's really like a pretty huge subject.
Yeah.
But overall, definitely DMExec, DMIO, DMOS, DMIO are useful to start looking more deeply into.
Is there a class available just on performance with SQL Server?
No, that's basically all of these are performance related.
Okay. Yeah. All right, stored procedures. We can also use stored procedures, and with stored procedures, we've referenced those a few times. We have system stored procedures. We have user-defined stored procedures that can be created. So with stored procedures, what we can do here is we can execute them. And the example here is we're just going to execute, SP databases. We're not going to pass any parameters. I want a list of all the databases that are available. Of course, I could pass a specific database name. It would give me information about that particular database. Same with the SP help. I just want general information about the table. I can actually get that information by typing SP help. If there's a specific table, in this case here, sales.customer, I can supply a parameter for that and get specific information about that single table. So it depends what you're looking for. I can get information about every database, about every table if I want to, about the system if I want to, about a specific table using SP_tables. It depends what I'm looking for. I can decide to just give me information about everything, or specific objects if I'm focusing on a particular object that I'm trying to fix or optimize.
And typically there are some exceptions. SP_help is very useful because it just gives you a lot of information about an object. But typically, you're better off looking at catalog views, so selecting from sys.databases or sys.objects, sys.tables, sys.procedures, and so on, sys.foreign keys, and so on, rather than using these legacy stored procedures. So a lot of them are the way you used to retrieve metadata back in the day, and we're keeping them for backwards compatibility. But the richness that you get from querying catalog views and DMVs are typically way greater.
So common system store procedures, we just look at a few of these: SP databases, SP tables, SP columns. Again, we're going to look at the use of the dynamic management views or DMVs or system catalogs are ways for us to access this similar information. Unlike the system views, there's not an option to select which columns to return. So if I want some information about SP databases, I type in SP databases. If I supply a database name, I get all the information about that database name. I can't be picking and choosing what information I want about that database or about that table or about the columns. But we have a little bit more flexibility when we're using the system catalogs or the views and the functions that are available to us. We can execute a system store procedure. Most of these are marked with SP underscore as the prefix. They're stored. The system stored procedures are stored in a fifth system database. It's a hidden database that's not displayed when you go into the SQL Server Management Studio. It appears in the sys schema of every user and system database. The best practice for execution include using the exec or execute statement rather than just typing in the store procedure name. You want to include the sys schema name so it knows exactly what you're calling out, so there's not any issues with the naming convention. And you can name each parameter and specify the appropriate data type. So they're showing again another store procedure down here with a parameter of object name, and we're calling out the table called customer. So we're specifying what it is that we want to see here. But what we need, again, if I could execute this SP help with provides a ton of information, but it'll probably be overwhelming with the type of information it's providing me, and it's not going to give you the detail that you want to, or it's going to give you too much detail. It's not going to give you the detail filtered in a way for you to be able to access that content. Your store procedures can be wrappers for simple or more complex statements, and we can use the create procedure statement for building these if we want to create a new store procedure. And this is a way to create a procedure here. We're creating one called products by product line. We're going to use the @numRows as int, so we're going to create a couple variables. We saw that earlier on, how to do so. We're going to select the top number of rows based on the number of rows that were passed in. And we're going to grab the product ID, name, and list price from the product table, where the product line equal the prod line, which is a variable that we actually passed in as well. So this procedure is going to allow us to pass a couple parameters. Let's limit the number of rows, but we want to return information from the products table based on a particular product line. But we have some control over what's being returned to us, even though we're using a stored procedure. We can pass it parameters. This itself, I would pass in this example here, the production.products by product line. I only want to see 50 rows. I want to look at the product line with the M category. So I would pass that, and I would get a result set from that, giving me information specifically about that product line. But I don't want to see every product within that product line. I only want to see 50 of them. So this gives us information about that. So we're using a select top. We're going to get the top 50 with that. And we can do an order by clause in here that would give us return that content in a specific order.
Okay, I can go ahead and just show an example of using a stored procedure related to just the banking app that we did before. So let me actually just grab that example that we already had. And we are publishing these script examples that we do. So the demos are online for you to download under the FAQ section of the website. So let me just grab the V4 of this thing, and let's say that this is actually what we wanted to make into a stored procedure. So that would make more sense.
Yes.
And stored procedures are good for various reasons. One of which is just management of code, right? So it's also that you don't have to generate all of this code on the client side. You can just send the procedure name and the parameter values to the server, and we'll go ahead and execute that. So I'll call this create procedure SP, let's say account withdraw. And we'll have some bugs in it, but that we won't worry about. So I have to pass in account ID, and I have to pass in the amount. And we remember both of them were ints.
Right.
And you don't actually need begin end in the beginning of the procedure, but I typically put it there for because it looks nice.
Yes, it does.
Set no count on is fairly common to use. It just means that after each statement, we don't return number of rows affected back to the client. There are some client drivers that will believe that that will basically interpret that as an empty result set. So it's fairly common that you do set no count on to also reduce the amount of data sent back to the client. And then I just go ahead and kind of replace here and say, well, this is actually this guy, and that's this guy, and account ID is this guy, and then we're good. So now I've created this store procedure, and we can go ahead and execute it. And it's definitely recommended that you pass the values in by name. So that means I specify this parameter name, and I say, well, this is account ID something, and amount that I want to withdraw is, let's say, 100. And this account doesn't exist, so I'll get the error message back. But obviously now it's way easier for you as the app runs, right? You don't have to change the app if you need to optimize the procedure. There are lots of discussions to be had with regards to where the app code should lie and so on. But that's one of the reasons. There's also reasons of we can cache the execution plan that we have to build to run this on the server side, which minimizes CPU that we have to go through in order to go and execute this. The other thing that's useful is also we don't have to go and parse and do all of that, all that work when we get the call, because if you just use a remote procedure call, you'll just say use this name with these values and go, and which definitely can give you a performance boost. But that's basically how you simply create the procedure and run it.
All right, and we get to expand on our example on the checking account in our banking industry, or a banking option that didn't quite work out like we had hoped because V4 was rolled out.
Yeah.
All right, so we looked at the performance, or we've been looking at different types of queries, whether they be specifically, we spent a lot of time on select statements. Let's take a look at improving SQL query performance, writing well-performed queries. So let's just some basic ideas here. So only retrieve what you need. So in the select clause, if you only need 2 or 3 columns, specify those columns instead of doing, specifying, the asterisk, which brings back or returns all the columns for you. If you don't need all the rows, use a where clause. So you're not causing any additional performance on the server. So be very specific about what you want retrieved. You can improve search performance of the where clause. Avoid expressions that manipulate columns in the predicate. So be fairly straightforward with the type of information that you want returned to you. Minimize the use of temporary tables or table variables. Use Windows functions or some of the set-based operations that we talked about earlier on in the class today. Avoid cursors and any other iterative approaches. Those require some extra overhead that would slow down your query performance. Work with your DBA to arrange good indexes and to support the filters and the joins and the ordering. So if you're coming in new, maybe you're a SharePoint person and you want to work with your DBA because you want to roll out SharePoint, which is installed on top of SQL Server. You and your DBA, my recommendation is you and your DBA should have lunch once a month. You should take your DBA to lunch once a month and spend some time with them and understand what they're doing and why they're doing. If they're doing an upgrades, you may be planning on going on vacation at the end of October, and you're finding out, well, they're rolling out they're upgrading from 2008 of SQL Server to 2012. Well, that might cause you to change your vacation plans. There's things like that you will learn by just having a conversation. There's things you may learn about SharePoint that you can talk to your DBA about and say, hey, look, I understand that if we do this in SQL Server, it'll help me in my SharePoint world. So just getting to understand or know your DBA or DBAs, your team of DBAs, and having good camaraderie with them will be important for you to help them and help you improve the performance with some of your queries, because you can indicate to them what you're doing, for joins and what you're doing for sorts. It's like, oh, maybe we need to put an index on that particular thing. Depends on how large of a shop that you're running or a business that you're in. Those conversations can be beneficial to both of you by spending some time with your DBAs. Learn how to address different tasks with different query approaches. We've looked at different ways for doing, there's a few things that Tobias showed us today that were like, wow, we can do it that way, or we can do it this way, or we can do it that way. So there's so many, often different flavors or different ways we can slice and dice the content. Try to find out the best way for us in performance-wise so you can improve performance by using the most appropriate or the best way for us to do that, knowing that there's a little less overhead involved with one way versus another way. Indexing in SQL Server, we talked about a little bit about indexes. SQL Server can access the query optimizer, determines whether it's going to retrieve content using a table scan, which means it's going to read everything in that table, or it's going to check to see, oh wow, we've got an index on this or indexes on that particular table. It may be faster for us to access this content using an index. So index are often used if you're grouping or joining or using that order by clause. And if it'll help you avoid the table scan, that would be beneficial to you when you're performing a query on your database that's stored in SQL Server. Index performance considerations. Check your query execution plans to see if their indexes are present. Make sure those are being used when you expect them to be used. You can over-index. You don't want people to think, oh, everything, if I'm going to apply an index to every column because it improves performance. Well, if you have too many indexes, it doesn't improve performance. And remember, indexes are beneficial when you're retrieving content, but there is a little bit of an issue or performance concern when you're inserting update content. And so if you start adding multiple indexes, thinking everything's going to be, much faster if you have all these indexes, if you have every column index, that's not true. It's something that you don't want to do. So for those query writers who aren't DBAs or developers, you need to understand the overhead involved with indexes and not just focus on the idea that, oh wow, indexes are going to help me improve my performance when I retrieve content. You need to understand that too many indexes is bad and there's some overhead involved when you're inserting and updating content that's on a table that has indexes. Your distribution statistics describe the distribution and uniqueness or selectivity of your data. By default, your statistics are created and updated automatically. You can update content if you just did a bulk insert of some data and you want the query optimizer to be able to take advantage of the index that's on there. You can actually force your index or your statistics to be updated. It's all driven by statistics. And your query optimizer looks at the statistics and is trying to determine which index to use. So these are items that you may want to look at and understand. For the most part, I don't need to be worried about updating statistics. It's done for me. But there might be options or a task that you perform which would require you to update those statistics and give you better performance with your indexes. Cursors kind of contradict the relational model, which operates on sets of data. Typically require more code, more overhead. Some alternatives to that are the aggregate functions that we introduce, windowing functions that we've introduced. There are some unique situations for cursors, like generating dynamic SQL code and performing some of the administrative tasks that we perform. Because remember, we've been looking at retrieving content and more from an end user or developer or information worker. Remember, all the tasks that the DBA performs for managing SQL Server are done using stored procedures and DMVs and executing queries similar to what we've executed. So these can be used as options as well. So improving query performance, any suggestions on that?
So I would suggest we hold on the demo and then we can go, once we go through the execution plan bit, okay. I can show a bit more demos around query performance indexing and looking at the execution plan.
All right, excellent. So we're going to come back to this demo because we're going to move into the next section, which is monitoring SQL Server. And Tobias, he kind of just really touched on it a little bit when he actually was in a demo earlier. He brought up the execution plan. He showed you a couple ideas. So we're going to expand on that a little bit more here. The execution plan is, what's the process involved with executing a query? There's the parsing, resolving any variables or any components that need to be resolved, optimizing it, compiling it, and then finally executing it. It sounds like a lot when you say it that way. It's done in split seconds, but that's all required when we're actually executing a query. There's some tools that are available to us for accessing execution plans to show how a query was executed or how it could be executed. We had a question in the chat earlier on, the query plans. What's the difference if you the actual or the the actual and what's the other one? We'll see it when we go in there. I can't forget. I just answered that question on the last break, and I'm already having a brain cramp. But the estimated. So the estimated is like it doesn't actually execute the query plan or the query. It says if I did execute it, this is what I would use. This is the results that you would see, or this is how that query would be executed. Where the actual, it actually performs the query that you're trying to execute, and it gives you the results as well. That's the question I was thinking about. Oh, and there's a slide on that, which I didn't realize that was coming up. I thought that was a few slides away. But here's an example of that.
Are you getting tired, Brian?
Apparently, it's like, wow, it's the next slide. All I had to hit the down arrow. And the answer was in front of me. So, yeah, here's the estimated execution plan. It does not execute the query. Just displays how it would execute the plan. Here's the actual. It's going to return the next time the query is executed. And these are the plans that was actually used by the SQL server chosen by the optimizer when that query was executed. All right, so now I'm going to look before I actually speak. All right, here's how I get access to the estimated execution plan. I can display that here and also include the actual execution plan. So we'll be able to see, Tobias is going to demo that for us when we go into the demo here. And he's also going to talk about how to interpret it. What does this mean? Because you can hover over these icons as you're seeing them.
I was going to talk about the Disneyland trip.
Oh, the Disneyland. I thought we couldn't do that because the V4 fixed everything.
Well, we got 2 or 3.
Fast. Well, we got a few. Yeah, we got a little bit of money. That'll get us through the weekend at least. So read the plan right to left, top to bottom. Hover the mouse pointer over. He'll show you that when we get in there. The thickness of lines between operators indicates the relative number of rows passing through. So, I mean, there's some visual items that are going on that you should be familiar with because that'll give you an idea as to what's happening. So the visuals, in addition to the rollovers of detailed information, will be beneficial when you're looking at the query plans and how to optimize or how to interpret those query plans. Again, here's set statistics time on or set statistics IO on. This gives us information about the parsing and compiling of a query, or the amount of disk activity generated by a query. So this is information that will give you additional information, or these are commands that give you additional information about how the query optimizer is working for us here. All right, you're off to a really cool demo, aren't you? You're smiling. Yes. I can tell you got something really groovy, jazzed up.
We'll sneak around here and have a look.
All right.
So, let's take a look at what we can do to improve query performance and understand what's going on. And this topic is obviously more than what you would fit in a few minutes of demo, but this is to give you kind of an insight into where to start and what there is to think about. So I'll just start by stealing this sales.sales order detail table, and we'll use that as kind of the example for the demo. So I'll just make a copy of that sales.index test, we'll just call it. Okay. So now this table is what's called a heap, and that means there's no clustered index on the table. And okay, what's a clustered index? Well, a table can be of 3 types in SQL Server 2014. In SQL Server 2012, which is the current version, we can be 2 types. So it can either be a heap, which is just non-sorted bunch of rows, or it could be a clustered index, which means it's sorted on some row. So let me just use a simple system procedure here to just check what's the current indexes on this table.
Are you going to leave us dangling on the new index in 2014?
Well, yeah. So we already have public betas out there with it, but there's new types of indexes in SQL Server 2014.
Looking forward.
So that seems pretty clear. Testing does not have any indexes, which means by definition has to be also a heap. So let's just try and say, okay, we want to run our query on this, and we'll use just a bit of a complex, but a bit of a query with multiple parts to it, so you get some insight into what's going on. So let's say that what I want here is by sales order ID. So by order, I would like the sum of unit price multiplied by order quantity, I think the column is, group by sales order ID, and I want this only where for a certain customer. So where customer ID, and that's a bit too broad. Let's see.
There you go.
Let's see if we can get something that is a bit more interesting. Special offer ID. Let's use that as an example. So, okay, where special offer ID is 1. Group by sales order ID. So now, and then let's add also, finally, we want this sorted by this total field. So that's the full query that we have from start. Okay, and it's fast. So done. Heading home.
That's it, right? Exactly. We had to go to the bank.
So let's turn on this execution plan business. So I'll click this one, include actual execution plan. There's really no reason to go and look at the estimated execution plan unless the query takes a long time to run, or possibly it's an update statement that you don't want to run it, right? Update, delete, or something like this. So a non-select statement. So I include the actual execution plan, run it again, and we'll see what SQL Server actually did. Apparently we did a table scan, okay? So we see there the predicate that it applied during the table scan, it actually looked for special offer ID equals 1 when it scanned. So this means it went through all of the rows in the table. And the thickness of the arrow is important, like Brian mentioned. So we see all of the rows that match this go to the next step, where there is a compute scaler. And if you go and hit properties here, you can see exactly what the definition of this computation is. So the computation is apparently this, which, if you just look at it, it's gonna take the unit price and multiply that by the order quantity. Okay, so that's apparently what we do there. Then we take that and move into a hash match aggregate. So that's the grouping.
That's my favorite.
That's the grouping, and the grouping we can either do a sort to group, or we can use a hash operation in order to sort it with. And apparently we decided to use a hash match rather than the sort, which is typically, which is definitely more efficient. Now, when you see a hash match aggregate, that's typically an indication that you don't have the right index in place. And just like Brian mentioned, if you create perfect indexes for all queries, you'll end up with index sprawl. And if you have 100 indexes on a table, that means that table is actually 101 tables, right? So if you do an insert, it's 101 inserts, so that can be costly, right? And then we apparently do the sort, the order by total at the end. So we even get a suggestion here from the engine saying, hey, what if you create this index? And you can actually right-click and say, give me the missing index details, and we can just go and create that. But let's look at this in a bit more detail. So we'll turn on the statistics I/O. That's typically the most interesting one to look at because the I/O used is independent of the locks that happen during the execution and how busy the server is, rather than statistics time, which obviously depends a lot on how busy CPU is and so on, and locking and all of that. So I'll execute this again. We look at messages, and it tells me per table how much work we did. And we can see here that we looked at index 1 and we scanned it once. During those 1 scans, we read 1494 pages, which are 8K units, from memory. So if it said, 10 here, that's during those 10 iterations through the table, the total was 1494. And then physical reads is out of those 1494, how many did I have to go to disk to fetch? And it makes sense that these are in memory since we just created the table, right? And then we have some more detailed data, which type of lookups we did. But basically, the fewer of these, the better. That's the general rule of thumb. So let's say that, okay, this one was actually this many pages, and we had a table scan, and we had a hash thingy in there, and hash aggregate, and we also, well, that's enough. And we will indicate that this is not perfect, right? So what you're interested in when you look at the execution plan is typically a smaller plan is better, fewer steps, that kind of makes sense. Thinner arrows are better, less values move between. And you want to avoid things that seem to use, touch a lot of data. So scans generally are not the best. And these hash operations are costly because we're putting lots of stuff into memory in order to probe the results, probe the hash table. So let's say, okay, let's create an index on this table. So we'll create a clustered index first, just to see what would happen. So the clustered index, I can specify up to 16, or always with indexes, I can specify up to 16 columns in the key. The key can't be larger than 16 columns or 900 bytes wide. And the clustered index is sorting the actual table. So you're basically sorting the table and then you're adding a balanced tree structure on top of the table. And the logical query processing is typically what you're after. What has to happen first is where. So we probably want to use the special offer ID as the first column in the index. Now let's just do this as the example. Create the index and then run the query and see if there is a difference. So now we see, there's a clustered index seek that happens instead. It takes the rows, goes to the next place, it calculates unit price times order quantity, does the hash match still, and then the sort. And now we ended up touching, more pages. Well, what's going on? Well, apparently special offer ID is pretty big, right? So when we restructured the table, we were unlucky in a sense that we actually ended up using more space. So that was obviously perfectly rehearsed. Let's do special offer ID 2. And let's drop the index and try again. See if Tobias fat finger again. Okay, so 1592. So dropping the index, obviously, it's not like we go and move everything around again. We just drop that balanced tree structure. So, okay, now table scan, special offer ID. Is it the same amount of rows?
I think it was.
Oh, sorry, it's a table scan.
Yeah.
It's getting late here. So, okay, 1592 pages, table scan, hash aggregate, all sad.
Yeah.
Okay, now we create the clustered index. Do this again. Special offer ID 2 is hopefully a bit smaller than 1. And yay!
Yeah, 48.
48 logical reads.
Nice.
Now we can go home.
Yeah. Now we're up.
Okay, so 48 pages, and we see this is an index seek. And that basically means we're using the balanced tree structure to walk it down, to find the right place in the index, and then just follow the linked list until we find special offer ID not 2 anymore, 3. But we still have a hash aggregate, so I'll probably say this is great, but let's just say it's okay. Yeah. Now I want to show the problem with the clustered index is obviously that we can create only one because you're structuring the table itself. So let's say we already had a good clustered index and we can't create another one. So let's say that there is already a clustered index on let's say there is already a clustered index on on sales order ID, which I'm not using in this query. So that and this is the common thing that you'll find when you're optimizing queries. There already is a clustered index there, and changing it, you have to obviously look at what problems you're creating. Okay, so this seems so now we're in this other space where we have to create non-clustered indexes. A non-clustered index means basically take whatever columns I asked to include, right, in the index, and create a new table, shove all of the data in there, but only those columns, and add a pointer back to the table. And there are a little bit different types of pointers you can read up on later, but put those in that separate table, build the balanced tree structure, and now you allow the query optimizer to pick that index as well. And you can imagine if you create 100 of those, you have 101 tables, right, like I mentioned before. So, we have this new index, and it's now the clustered index is not on the right column anymore, right? It's on not special offer ID. So we're back to having a clustered index scan, which is the same as a table scan. So I'm scanning the clustered index, which is the table, right? It's just a sorted table. So, and we're getting this 1574 pages. So let's just pretend it's the same as this. So I want to improve on this. I'll go ahead and create a non-clustered index. And you can have up to 249 non-clustered indexes on a table, but you probably don't want that. And I want to have this index on special offer ID, which is basically the same as before. Now what happens is we take just special offer ID, copy that to a new table, sort it, create this balance tree structure, and have the pointers back. Create that index, and let's run the query. Still 1574. Well, that's odd. What's going on? So, still doing the clustered index scan. Oh, so the query optimizer didn't notice it was this great index there. I can go and force the index to be used instead. So we'll say with index, and this is typically something that you do mostly for testing. Add index hints. So basically, when you access this table, I want you to go through the physical structure NCEDX, the non-clustered index I created. So now I know better than the query optimizer, so I'm telling it, boss, you have it all wrong. Let's do it this way instead. And now the execution plan looks like this. We seek the index, so we go to this other structure, we find special offer ID 2, but for every row I have to go and fetch unit price, order quantity, and sales order ID, because those don't exist in the table. Actually, sales order ID happens to be the pointer in this case, but at any rate, logically, you have to go and fetch these from the base table. So now for every row in the that we're returning, you have to go and fetch from the base table, which becomes a lot of IOs, right? So now we're actually using 10,570 IOs. And you're doing a join here between these two tables, in essence, behind the scenes. So, wow, that's tables, that's basically index seek plus lookup to get the rest of the columns that were not in the index. And then apparently we could do the aggregate immediately. And then this is super bad, obviously. Now we made it worse. So let's see, what could we do instead? Well, we don't obviously want to have to do these lookups. So I'll say, well, special offer ID I want in there, and I want to include, and I'll just move the clustered index to another column to make another point. So let's just put the clustered index on order quantity. There we go. And obviously, when I rebuild the clustered index, I have to rebuild the non-clustered index. So now we want to improve on this. So we say special offer ID, it's the index. And I can also choose to include additional columns in the index just to avoid these lookups. So I say, well, I need sales order ID in there because I group by sales order ID. And I need unit price and order quantity in there. If I have all of those, it shouldn't need to do the join down back to the base table. So I'll go ahead and recreate the table, the index. So again, it sorts based on special offer ID and just then adds into the index these other columns. Now when I go execute that, I get 17 logical reads. Or it sounds better, right? And if you go and look in the execution plan now, it's clearly just a seek, computes the scalar aggregate. Then we have a sort. And if you look at the cost estimate here, that's where we're spending a lot of the cost of the query. So we're sorting on sales order ID because of the grouping. Right? So apparently the query optimizer came to the conclusion that this is a small enough set. Right. It makes sense to sort rather than hash aggregate. So we have index seek, we have sort for grouping. And this is already good, right? We went from 1,500 odd logical reads or pages down to 17. But let's see if we can do better, right? So what we can do is, if we already sort this on special offer ID, that's the where clause. The next thing that's going to happen is the grouping. So if the index is already grouped or ordered on sales order ID, since that's what I group on, I won't need to do the sort operation. So I recreate the index, and I go and run the query again. And now still 17 logical reads because it's the same amount of data I need to touch. But you can see that the sort operation disappeared, the first one, right? Because the grouping, you can just go and do the stream aggregate. We know that it's already sorted, so we just go and do the calculation. And then we have the last sort, which we need because we want to the presentation to be ordered this way. So now you can argue this is kind of the perfect plan for this particular query. So 17 pages, index sort, and then no sort for the grouping. And this is, super happy.
Nice.
So obviously, if the query runs, you execute this all the time, it's a good idea to create the right index. If you execute it some of the time, at some point, you'll have to think about this index sprawl business. But this kind of gives you an insight into what you need to do in order to get the best performance out of your queries.
All right, fantastic demo to wrap up this module here. We're just going to do a little brief summary here. We talked about system catalog views and ways for us to review that content or access that content. Information schema views. We also have some stored procedures, system stored procedures. But as we pointed out, you want to try to take advantage of the system catalog views as well as the information schema views to retrieve information, or then the dynamic management views or the DMVs. We showed you how to create a stored procedure and how to include passing the parameters into a stored procedure so you can reuse that stored procedure and be able to retrieve information based on different values that you're passing in. Writing, we talked about ways to improve performance with your queries by avoiding certain things like cursors and only specifying the columns that you really want returned versus all the columns, using a where clause versus no where clause, which is going to return all the rows. And we looked at the ways for us to monitor the performance of a query, and with the excellent demo that we did with the Tobias did actually with the query plans, how we can use those execution plans to view the content and understand if there's better ways for us to be able to access this content. And as you saw, we tried 3 or 4 different iterative approaches before we found the best solution for that query or for that index. So what we did today is we went through an introduction to SQL Server. We talked about the different types of statements and introduced the basic select statement and other statement elements. We went into advanced select statements. We introduced distinct, aliases, scalar, functions, and case. Talked about joins and merges, how to filter and sort your data. Talked about the different data types, the date-time data type, the character data type. Also, understanding SQL Server function types are available to provide information back to you. We looked at ways for grouping and aggregating data. We used the group by and having clause. We introduced subqueries, how those can be used. The exist clause. We talked about the inline and the derived tables that are available to us. We actually broke for some food somewhere in the middle, so we took a meal break today, which was good, all needed. And then we talked about the set operators and how we can use the grouping sets like pivot and cube and roll up. We went into ways for inserting, updating, and deleting data. Talked about the use of default constraints and triggers to ensure that data we're adding is valid data or good data we'll use, and to avoid the garbage in, garbage out. We talked about programming with SQL Server and how to implement error handling, and also introduced the idea of transactions, how beneficial and how they could be required depending on the type of data. Obviously, the banking industry does require the use of transactions. And we've wrapped up with retrieving SQL Server metadata, improving query performance by querying system catalogs and DMVs, and looking at creating and executing store procedures, and then how you can improve SQL Server query performance by using those execution plans. So on behalf of everyone here at MVA, as well as Tobias and myself, it was a pleasure working with you. We would like to thank you very much for joining us. We'd like to ask you as well to look at the poll at the bottom of the screen. If you take a few moments to complete that, we would greatly appreciate it. And we appreciate you joining us, and we look forward to seeing you in a future MVA class.
Thanks a lot,
much.
everyone.